These are the complete solutions to the self-assessment for 1-1 to 1-4. So if find k of 4c if k of x is equal to x squared plus 2x minus 4. This was called function notation. The way function notation worked is you take that 4c and you replace every x with it. So 4c squared plus 2 times 4c minus 4. And then after you replace all the x's with 4c's, you simplify. So 4c squared is 16c squared. 2 times 4c is 8c. And there's where 16c squared plus 8c minus 4 came from. This one's a little bit harder because you're plugging in m plus 2 in place of both of those x's. So you get m plus 2 squared minus m plus 2 plus 3. Now notice when I plugged in m plus 2 in place of the x, I put it in parentheses. When you square m plus 2, you need to do this. A lot of times people want to distribute the exponent, and that is not how it works. Squaring means writing it twice, and then you use FOIL. First, outside, inside, last. The next part of the problem, you're going to distribute the negative. It's really the same as multiplying everything in the parentheses by -1. So you'll get negative m and negative 2. And we don't want to forget about that plus 3 at the very end. Well, now that we've squared m plus 2 and we've distributed the negative, now we want to go and combine our like terms. There's nothing to combine with m squared. There are 3 m's, so 2m plus 2m minus m is 3m. And then 4 minus 2 is 2, plus 3 is 5. And that's where m squared plus 3m plus 5 comes from. This was operations on functions. And the first notation here is really just asking you to add x squared plus 4x plus x minus 2. That's all it is. It's just a different notation for adding two functions. When you add two functions, you just combine like terms. These are your like terms, so it's x squared plus 5x minus 2. And I just realized I made a mistake on this one on my answer key when I went through the quiz. So when I go back and look at your quizzes, I will look for that mistake. F minus g is the same as subtracting the two functions, but when you subtract them, you have to be careful. Notice that I'm putting it in parentheses. The reason I'm doing that is because I have to distribute this negative. So I get x squared plus 4x minus x plus 2, which is going to be x squared plus 3x plus 2. F times g of x, that's just telling us to multiply the two functions. When I multiply those two functions together, I'm going to use FOIL. So x cubed minus 2x squared plus 4x squared minus 8x. I have some like terms to combine. The middle terms are like terms, so I'm going to get x cubed plus 2x squared minus 8x, which I also screwed up on my answer key, so I'm going to have to look at that one again too. Sorry, I am having a bad math day. All right, D, f over g of x. All you have to do is put the function f in the numerator of a fraction and put g in the denominator, and that was it. Down here, this was called a composition of functions. You might have also seen the notation like this. I called it fog notation because that's what it looked like. I don't like that notation. I like this notation because the way that it works is it says plug this function into this function everywhere you see an x. So in the function x squared plus 4x, I'm going to take G and I'm going to plug it in everywhere I see an X. So I'm going to get, I'm going to get X minus 2 squared plus 4 times X minus 2. Remember, when I multiply this out, I have to write X minus 2 twice and then FOIL it. X squared minus 4X, minus 2X, minus 2X plus 4. And then we'll distribute this 4 over here. So we have a plus 4X minus 8 at the end. And then I'm going to combine my like terms. I get X squared. Negative 2X is negative 4X. Plus 4X is 0. And then 4 minus 8 is negative 4. G of f of x goes the other direction. It says plug f into G. So you take the expression next to f and plug it in everywhere in G where you see an x. Well, you end up with x squared plus 4x minus 2. And there's nothing you can do to that, so that's the answer, although we don't normally write it with the parentheses. In number 4, we asked you to find the domain. These are the two types of domains that occur most frequently for us. We'll learn some new ones this year when we study trigonometry. When studying domains in Algebra 2, there were only two things you had to look for. You had to look for radicals and fractions. The reason is because with a radical, you cannot have a negative. So you know that the quantity underneath the radical has to be greater than or equal to 0. Otherwise, it's negative, and the square root of a negative was an imaginary number. It's not even a real number. Well, this is just a simple inequality to solve, and it turns out that x has to be greater than or equal to 16. That's the domain. For fractions, there's only one number in the world that you can't have in the denominator of a fraction, and it's 0. So what we do is we say that the denominator cannot equal 0. And then we solve that for x. So x cannot equal 4. For number 5, the 0 of a function is where y is 0. Please do not forget that f of x is the same thing as y. Now, if to do is solve that for x, you add 3 and you divide by 2. By the way, the 0 is also a y-intercept. X-intercept. All right, last problem. In 6a, we gave you the slope and the y-intercept and asked you to write the equation in slope-intercept form. Slope-intercept form is y equals mx plus b. So for the first one, it's just y equals 2x minus 3, because m is the slope and b is the y-intercept. In part B, though, we tell you the slope, but I don't tell you the y-intercept. So what do you do if you just know a point on the line and you need to find b? There are a couple different ways of doing it. Probably the most straightforward way is to plug this ordered pair in for x and y and solve for b. So 1/2 times negative 5 is negative 5 halves. And then you have to add 5 halves to both sides. And 2 plus 5 halves is 9 halves, or 4.5. So the equation is y equals 1/2 x plus 9 halves. The last problem, I give you just 2 points on a line. I don't tell you the slope or the y-intercept. To find the slope, you can use the slope formula. y2 minus y1 over x2 minus x1. So 5 minus 2 over 2 minus negative 4. 5 minus 2 is 3, 2 minus negative 4 is 6, and 3 over 6 reduces to 1/2. So the slope is 1/2. To find the y-intercept b, you can do it the same way I did in part B, where you pick just one of the ordered pairs and plug it in for x and y. But I'm going to show you another way. There's another way to write the equation of a line. It's called point slope form. If you know the slope and you know a point on the line, I'm going to use this point. So I'm going to use y minus 5 is equal to 1/2 x minus 2. And then you can distribute and then add the 5, and now you're in slope-intercept form. The other way you could have done it was you could have instead started with y equals 1/2 x plus b, and then take the same ordered pair where you plug in 5 for y and 2 for x, and solve that equation for b. Well, 1/2 times 2 is 1, and then you subtract 1 and you find out that b is 4, and that's how I got 4 here. So your job now is to go back over the problems you got wrong, and we'll go back and we'll double check the 2 that I misdid. And you're going to watch videos on educreation and do some practice problems in order to relearn the material before we test you officially on this material.